Hello, good people. This is the optional video explaining about number three. Number three was inconclusive according to the nth term test. We don't know whether this infinite series converges or diverges. However, I told you that this was a special series. It actually has a name, and it's called the harmonic series. And if I were to write out the terms would look like this. I'm supposed to substitute this number into the formula to get the first term. So I plug in 1, that'd be 1 over 1. That's just 1. But then I'm supposed to substitute subsequent numbers, right? So substitute 2, that's 1 half. Substitute 3, that's 1/3, 1/4, 1/5. So the harmonic series is really the sum of the unit fractions: 1 half, 1/3, 1/4, 1/5, 1/6, 1/7, and so on. So I went ahead and wrote this out for a couple of more terms. 11 plus 1/12 plus 1/13, and so on, right? So here's a quick proof just to show you that the harmonic series diverges. It always diverges. Even though the numbers are getting smaller and smaller and approaching zero, the whole series itself diverges. And here's why. I have the harmonic series written here. But what I'm going to do is right under it, I'm going to write kind of like a parallel series. So I have 1, and I'm going to add 1 half, right? Now, I'm supposed to add 1/3 plus 1/4. But let's say I add 1/4 plus 1/4. So instead of 1/3, I'm going to add 1/4 plus 1/4. What does this give me? 1 half. And I'm supposed to add 1/5 plus 1/6 plus 1/7 plus 1/8. But what does this give me? What if I say I'm going to replace this with 1/8, 1/8, 1/8, 1/8? What does this add up to? 1 half. Plus, by the way, this green series that I'm writing down here has smaller values than the harmonic series, right? The harmonic series values are bigger. 1/3 is bigger than 1/4. 1/5 is bigger than 1/8. 1/7 is bigger than 1/8. But I'm using smaller values. And as I do that, all I'm doing is I'm noticing that, and if this one I can go to 1/16th, and I'll use the color that I used before. 1/16th plus 1/16th plus 1/16th plus 1/16th. I'm replacing every purple fraction after 1/8 with 1/16 all the way to 1/16th. So if I were writing this in purple, 1/14th, 1/15th, 1/16th plus yada yada yada. But what if I replaced all of these with 1/16th? This should be a smaller sum than that, right? And yet, when I add all of these 8 fractions, I get 1 half. So if I continue to do that forever, then really I'm just adding 1 plus 1 half plus 1 half plus 1 half plus 1 half. I'll add the next set, I'll add another 1 half. And it's just going to keep growing and growing and growing and growing and never stop. Now it's growing very slowly because I'm only adding 1 half every set of fractions, right? But here's the deal. The original series, the harmonic series, is actually bigger than the green one. So this is going to go to infinity, right? If the purple series has values that are bigger than the green series, and the green series is increasing without bound, then the purple series is going to increase without bound and therefore not be convergent. It'll be divergent. So later, when we talk about, excuse me, another test called the integral test, we'll definitely prove this for sure. But this is kind of an informal proof that says, hey, this, even though my fractions are getting smaller, if I continue to add an infinite number of them, it is going to diverge because I'm never going to settle towards a value. And so harmonic series, which follow this pattern, always diverge. That's going to be helpful in our future. I just wanted you to see a quick informal proof of how we can kind of prove to ourselves that this is a divergent series, even though the fractions are getting smaller and approaching zero.